Hi, good morning everyone. How are you? So today I'm going to explain how to do fire assay method. So this fire assay method, it will contain there's some steps coming. So this is fire assay method. One it is having there's a flow. I'm reporting here in one flow chart. It is sample receiving, sample sorting, sample drying, and crushing, then pulverizing, then fluxing, fusion, and cupellation method, acid digestion, AS analysis, then result reporting. So these are the flowcharts which we can involve with this fire assay method. So from now I'm going to explain one by one method, which is step-by-step process, which is from sample receiving to up to result analysis, AS finish. So for now I'm going to analyze with I'm now introducing lab operator, which is David. Is a lab operator. He is going to take through the process, complete process.
Okay, so as we receive our sample, it will be like this. When it comes to the lab, we will take this sample. First, we receive it and record it in the receiving book. And after receiving it, we have to dry the sample. We dry the sample, we put it into the oven, like this one. To dry our sample. Depending with the moisture content, some samples to take too much time. Some samples, like this one, the rocks, they take less time than the sands one.
If you check this one, it is a moisture content because this is coming from the milling. So it is a completely a slime. So we convert it into dry because when we do analyzing, we need a dry sample to do analysis. So this is the content it is a compartment which is 1, 2, 3, 4, 5 compartment, which is it is a capacity of 100 samples capacity, and also it have a heating elements. Can show this heating elements, which is we have a thermostat for also. We can set it to how many degrees if you want. So this we put a heating elements on top, heating element down to dry the samples. So this is insulated completely. It is a fire blanket inside. It is insulated, this micro oven, actually sample dry oven. So this is a control box which can control our temperatures, because some samples don't need too much temperature to dry. So we can able to control with this regulator. Yeah. So we are done with sample drying. Then we are moving into sample crusher. You can cut. Take it, sir.
Let's take our sample so that after drying our sample, we have to crush our sample from this size to my. This is our crusher, lab crusher. We need to want this sample to crush it to -2 millimeters so that we can take it to the next stage. So now we are now crushing our sample. This one.
So, as you see that the size of the sample, which is more than 50 millimeter, so we are crushing from more than 50 millimeter to between 2 millimeter to 5 millimeter. So this is a sample crusher. So we are from this crusher we are going to do next coning coating.
So we have to split our table to reduce its size so that we can take it to the next stage.
So on this one we are going to take this one as an analysis, and also we can keep it as a this is a table which can indicate our sample flow method. There is a series from left to right, right to left, so that we can put our order here. And also these crushing ridges we can save as a future reference to analysis. If customer need some again to send some other labs, we can keep it as a in our stock, so that whenever they want we can use this code to pull it out. Next. Then after
Crushing.
After crushing, this is very important. After crushing, because every sample to sample we need to clean thoroughly, because to avoid contamination. Because if one thing is one sample is contamination, whole process is going to be waste. So that's why we use air compressor to clean the system. Then we can use another sample to recrush again.
From the crusher, we now want to pulverize our sample. This is our pulverizer, left pulverizer. This consists of 3 bowels. As you can see, this is our sample. We want to pulverize it to powder, minus 75 microns. So we now want to put it. Yeah, we are back with our sample again. It's now powder, as you can see the state.
Where is that one? See this from this grain size, particle size to this powder. This is minus 75, because our most gold can liberate from minus 75, because from this stage to this one we are going to pulverize that. So that's why our gold can liberate from this powder. This is how we are doing pulverizing. So this pulverizing method, there is a different type of pulverizing machines. There is a 2-bolt, 3-bolt, and 5-bolt and 6-bolt. There is a multi-bolt. So the process time is same. Process everything is same, but only thing is cycle time it can different. So in our case, this is 3 pulverizer, 3-bolt pulverizer. So it is taking 6 minutes to do cycle process. So this is how to do pulverizing. So then after that, we are going to put our samples here in order. So our all samples is going to like each. We are doing our batch. Yeah. So we are doing 20 each batch 20 samples. So we are taking as a batch, same batch, to go for next stage. This is a fluxing method. So this is a fluxing room, sample weighing room and fluxing room. So we are now into this is a blower which extracts the hazardous fuels. Then this is a table, so which we can put our samples with a smooth flow. Then this is a weighing balance, so that it is calibrated, up to dated completely, so that we can take our sample to do weighing here, then to do fluxing.
Yeah, now we are at the fluxing stage, weighing stage. This is our sample. We want to weigh it. So we are using this prepaid flask, which is, so we are taking 100.
So this is a pre-mixed flux. So this pre-mixed flux, what is that? What is that? Yeah.
Well, this flask consists of, this is a 25 kg bag. It will consist of 30 litharge, soda ash, borax, silica, and millimil inside here. So the ratios are, there is the 30% borax, 30%, 40% soda ash, 20% borax, 10% millimil, and 10% silica inside here.
Yeah, so on this fluxing method, there are two different methods. One is we are going to mixing different ratios. So this ratio is for the universal method, but there is a different, because our ores are different, which is either oxides or sulfides. So when it comes to sulfides, we need to add more flux to liberate the gold. So that's why we use this premix fluxing method.
So after preparing our flux, we now want to take our sample. We take our sample, we have to shake it so that we mix it properly. Want to weigh our 50-gram sample. We have to take from different portion from different sides of the sample. We now have our sample here. The sample, 50 grams. We put it in a plastic. We are now weighing our flux 150.
Because we are going to use this
1:4 ratio.
1:4.
1:3, sorry. This is our flux 150 150 grams, our sample 50 grams. The ratio is 1:3. So we are now mixing our sample in the flask. Now we have mixed our sample. We now put, this is silver nitrate. We also use it on our process so that that's the one which will make pre-use in the next stage. So we are now putting 4 mils of silver nitrate. This is our sample, which is now ready for fusion.
So this is the order, because when you do fire assay, I mean fusion and cupellation furnace, we are keeping a standard order. We are putting a left to right, right to left, something like there is a order. So we are going to prepare a samples like this, then put in a order so that we can pick it same order until furnace firing. Fusion and cupellation furnace is finishing stage.
Now we have take our samples. We now want to put them into the furnace. This furnace. So these are the crucible which we use. So the order is from, this is our first sample to the last sample, from left to right. So we are now want to put them inside.
Show it.
So now putting our sample for the next hour so that the fusion process is now okay. As you can see, we put our sample here. So our furnace is temperature readings, which is, so as it reaches 1000 degrees Celsius, you need to go for an hour so that the fusion process occurs at 100 degrees Celsius. That's why the flask can now perform properly. If the temperature is low, let's say 800 degrees Celsius, we will be roasting the sample. It won't be fusing. So now, for an hour, if you give our sample 1 hour, you see the result. It will complete the process. So now we are taking our sample out. We have completed our process. This is our sample. That's what it will be looking like. This is after fusion. This is what our sample will be like. So these iron molds, that's where we pour our samples after fusion in the same order. We'll be maintaining our order so that we don't mix with the samples. After this, we are now want to go for the next stage. So from this, there's this one. This is our lead button that is carrying our mineral in the samples, either gold, silver, and other metals. So to hammer it, This is our lead button, which is now going for the next stage. Our sample is now going to the next stage, which is cupellation process. So this is the cupel. On the cupellation process, this cupel absorbs this lead, so that this lead button, so that we are left with gold and silver. So we have to put it into our muffle furnace. Our sample is now in the muffle furnace for cupellation. At this stage, also our muffle furnace have temperature readings, and the cupellation method occurs between 950 degrees to 1000. So we have to wait our temp for our furnace to reach 950 degrees. That will take about 5 minutes, because we opened our furnace, so it loses temperature. So now it's using the temperature so that it can reach the actual temperature we need.
Our lab operator has explained, Mr. David, so he did explain the process. Now I'm going to check through just all the structures, what it is here. So these are the crucibles, which is the capacity of to hold 50 grams of sample. So that because the size of this crucible, it can hold the 50 grams of sample. Then this is a muffle furnace. It have a glow bars. We are using heating elements as a glow bars, because this glow bars, it is it can take alternate current, AC current, to heat up the elements to use furnace. This is a small furnace which is a capacity of 25 samples. So there is a exhaust, which because when during furnace firing method, there is a hazardous fumes it is releasing. So those fumes, we are going to extract to the outside. So that is minimum 6 meters from our lab premises. Yeah. Then this is cupellation furnace. It is a small furnace, because after that muffle furnace, the gold, the mineral lead button, we are going to put into the cupellation. So this cupels, it can hold the lead, then can leave gold cream. So next process Mr. David is going to explain. So this is the cupellation furnace. This is which have some glow bars with the smaller size capacity. This is also operating with electricity. So this is a vent which can extract the fumes, because compared to muffle furnace, this cupellation furnace is having more gases, because it is bending lead fumes. Those lead fumes is very dangerous harmful to the human body. So that's why we put exhausting through this vent.
So we now complete the cupellation process. The cupellation process is now, we now complete our process. This is now our silver prill, which contains the silver and gold. All the lead is now being absorbed by this cupel. So now we want to take this to the next stage, which is the digestion stage. These are our components. This is nitric acid, hydrochloric acid, and this is lanthanum. So now put our prill into the test tube for the next stage. We now want to digest our super prill using nitric acid. So I'm going to put 1 ml nitric acid using a dropper, and you put it on the hot plate.
మొత్తం వీడియో కంటిన్యూ.
So as you can see, this is our fume hood. This is our hot plate, this is our fume hood, and this is our extraction fan, which we extract all the fumes, hazardous fumes outside, so that how it is arranged like so. Now we are turning on our fan. Our fan is on. So because you are digesting with acid, the fumes need to go up. This is now our silver has been digested. So we now want to put hydrochloric acid, 2 ml hydrochloric acid to add to 1 ml nitric acid, so that we now want to digest the gold in our sample. Now we are going to put it again on the hot plate for another 10 minutes, and we have to light our fan for the fumes to go outside. Now our sample has been digested. We now have our sample. We are now adding 1 ml lanthanum oxide. Add 1 ml lanthanum oxide to our sample, and we are now diluting up to 10 ml.
That's okay. Yes, got that.
So we have diluted to 10 ml. This is our sample. We now we shake it, and now it's ready to be analyzed. So we are now taking it to the next stage, which is analyzing stage, using the atomic absorption spectrometer machine. So we are now taking it to this stage.
So this is AS room. This room is equipped with aircon and also inverter system, and this is AS machine, and there's a compressor which is oil-free compressor, because it will take air and acetylene mixture to make a flame. So this is a oil-free compressor, and there's a table which can put our solutions here after digestion. Then there's a standards, gold standards here. It is 1 ppm, 2 ppm, up to some different ppms, and this is a samples here. Then there's a batch paper. It will come with this one, so that for adding that, for analyzing that. So, and this is a monitor which can connect it to AS machine, and this is a CPU which can support to monitor. So this is a printer for printing our result. So this is completely AS room. So this is analytic Xena Nova 800. So it is one of the AS machine to analyze minerals. So it is contained. We can analyze any minerals using halocathode lamp, because if you have for example, if you want to use lithium, if you want to use copper, we just need a halocathode lamps. Same lithium halocathode lamps, copper halocathode lamps, and gold halocathode lamps to analyze our samples. So that now this is the halocathode lamp. Actually, this is not working, but this is a halocathode lamp. It is a gold AU halocathode lamp, which can insert here. There is a turret is there inside, so that we can insert the halocathode lamp to use to AS atomic absorption. So now our operator going to take through how to analyze the sample.
Want to analyze our sample?
No, just
Analyzing our sample using our machine. We switched on our machine. It's now ready. So
wait. So as you can see, this is a shield which can protect hazardous gases. So this is a bin. So this is a bin, and this is a spray chamber, and this is a nebulizer which can take a sample to spray here, and there is a atomic absorption light. So that light, it can read our atoms which is firing through this line. So this is why we call AAS machine. AAS machine means atomic absorption spectrometer. So that is why we used to call AAS machine. So I am putting back now this shield to protect for the operator.
So we are reading our sample. This is distilled water. Now we immerse the sample tube into our sample. We are reading it. This is our graph where we can show our results. So this is our result here for the sample. This is this is the concentration of the column where we show the concentration, and here, as you can see, in the earlier stage we diluted our sample to 10 mils. So this is our dilution factor. This is the concentration, and this is now our dilution factor. So this will become our final result. So our sample is 10 ppm, meaning 10 grams per ton of gold. We have used a gold allocathode lamp to read the sample. So it was analyzing the gold in the sample. So we are now going to the next stage, which is reporting stage. We want to report the results.
See, so this compartment called to put our halocathode lamp, AU halocathode lamp. So far now we put our AU halocathode lamp here in compartment. Then this is a turret. We can insert any. This turret contains 8. So far now we put only one, which is gold AU halocathode. AU means it's a gold halocathode lamp.
Analyzing our sample, we have to put it on a report sheet. This is our lab sheet, and how it looks like. Those sample, these are the sample IDs. Says sample IDs, weight and concentration. So our sample will be like this: the sample ID, the weight, and the concentration. So that we'll log the information here on our sheet, and later we'll then enter this after logging several and analyzing more samples. We have to enter them into the computer for reporting. So this will be our sample IDs, the results, the process, and date received and reported. So this is how we report our samples. After entering in the computer, we have to send to the customer the results.
This is the process from sample. This is a process for fire assay method, from sample receiving to up to reporting AS analysis. So thank you very much for to encourage us. Thank you very much. Thank you for lab, our all supporting team. Thank you very much. Yeah, talk.
Okay, so we have showed you all the process from sample sweeping to the analysis and reporting. So we are saying thank you very much for watching.
This is the fire assay method. And our next video, we are going to explain bottle roll test. So how to do bottle roll test from sample preparation to up to analysis. So thank you for watching. Thank you for David.
Thank you.